These are the top 4 homemade lithium-ion battery auto charger that you won't find on any other channel. So, let's get started.
Hey there, in this video we're going to build an effective auto cutoff charger with just 2 components. This circuit can charge 12 volt to 3 volt battery. All you need to do is adjust the circuit to the battery maximum charge voltage. For lithium battery, we will set the voltage of the circuit to 4.2 or 4.1 volts, which is the maximum charge voltage for the lithium-ion battery. When the battery is fully charged, it remains at 4.2 volts and doesn't go above or below 4.2. And for those of you that are not subscribed to the channel, please be sure to do that and hit that notification bell so that you'll be notified if there's an upcoming video. So let's get started. To build this simple circuit, all you need is an IRF3205 MOSFET transistor, or you can as well use an IRF44 MOSFET transistor. And we'll also need a 560 ohm variable resistor. And you can also use a 1 kilo ohm variable resistor. So guys, for this project we're going to make use of only 2 pins of the variable resistor. So we're going to make use of the middle pin and any of the one from the left or the right. So first we're going to connect the gate pin of the MOSFET transistor to the first pin of the variable resistor. And then we're going to connect the drain of the MOSFET to the middle pin of the variable resistor. And then the source of our MOSFET transistor is going to be our negative output. And then the gate of the MOSFET transistor is going to be our negative input. And so guys, let's put the circuit together and see if it actually works. And so guys, to be able to set the voltage, we're going to connect an LED as a load to the circuit output, and then we're going to regulate the voltage to about 4.2 volts. This is a maximum voltage for a lithium-ion battery. And so guys, to see if this circuit actually works, we're going to connect a 4.2 fully charged lithium-ion battery to the circuit to see if it goes above 4.2 volts. And so guys, as you can see here, the battery voltage is 4.2. Now we're going to tune our emitters knob from 200 to 20 on the DC mode. This is done so that we can see any slight change in the voltage. And as you can see here, we have a voltage of 4.14 volts. And as I turn on the power supply, we have a voltage of 4.15 volts. And so guys, as you can see, the circuit actually works. So what we want to do now is connect a low voltage battery to see if it's going to charge. So now we're going to hook up a 2 volt battery to see if it's actually going to charge. And so guys, as you can see here, as I turn on the power supply, the voltage increases to 3 volts. So yeah, it actually works. And so guys, if you like this video, support us by subscribing to the channel and give us a thumbs up.
Hey there guys, so in this video I'm going to show you how to build an auto cutoff circuit for lithium-ion batteries that is very effective with only 2 components. This circuit is so effective that it will cut off the voltage of an 18650 battery when it reaches its maximum charge. And so guys, if you're new to this channel, hit that subscribe button so you can be a part of our channel and also you can find our new videos. So hit that subscribe button and let's get started. So why not buy a BMS charging module instead of building? So the problem with this BMS is that they could be easily damaged, and sometimes these circuits will not cut off when a battery is fully charged, just like this one that overcharged and destroyed my battery. And so I thought to myself, why buy one of these when I can build one that is very effective? So guys, let's get started. And so guys, for this project we're gonna need a 2 ohm resistor. This resistor will limit the amount of current that's flowing into the battery. And also we're gonna need a diode. And so guys, the diode has a voltage drop of 0.7 volts. And so guys, with the diode and the 2 ohm resistor connected together, we will have a total voltage drop of 4.2 volts at the output of the power supply. Now so guys, let's put these components together and see if it actually works. The resistor goes in first. And next we have the diode connected in series with the resistor. And no, this isn't AI, this is my actual voice. Sorry about that guys, so let's move on. So now that we have the resistor and the diode hooked up together, just like you've seen here in the video, we're going to measure the voltage of the battery. And as you can see here guys, we have a voltage of 3.76 volts. So this is the minimum voltage of the lithium-ion battery. So what we want to do is charge the battery to about 4.2 volts, which is at its maximum. And so guys, at this point we're gonna hook up the negative terminal of the battery to the positive terminal of the diode. So the reason why we're using a diode in this project is because we don't want the voltage from the battery to be flowing into the power supply, so the diode stops voltage flowing in one direction, so only the voltage from the power supply is going into the battery. Sorry about that guys. So we're gonna connect the negative terminal from the power supply to the resistor. So the negative voltage from the power supply flows into the resistor and then goes into the diode, which allows currents to flow in one direction and then flows into the battery. So now that that's done, we're gonna hook up the positive terminal from the power supply to the positive terminal of the battery. So my beautiful people, if you're actually enjoying this video, support the channel by hitting that subscribe button and being a part of it. And now by connecting the USB cord to the power supply, the battery should start charging. So now guys, now that that's done, we're gonna add in a indicator to indicate when it's charging. So I'm gonna use a 2K resistor here, but you can as well use a 1K resistor. And also I'm gonna use a red color LED for this project. So let's hook it up and see if it actually works. So we're using a 2K resistor here, which is going to be connected to the LED to limit the amount of current that's coming into the LED so that it wouldn't damage the LED. Because the voltage from the power supply is 5 volts, we need to reduce that voltage to the voltage that the LED needs to turn on.
So guys, as you can see here, the indicator comes on to show that there is power from the power supply coming into the battery. So if I take off the USB from the power supply, it turns off. As you can see here, it works perfectly well. So guys, to know if the circuit is automatically going to cut off when the battery is fully charged, we're going to let the battery sit for a while and charge to its maximum. And so guys, after some minutes of charging the battery, we have reached the maximum charge of the lithium-ion battery. As you can see here, when I pull up the cable from the power supply, we have 3.98 volts, but when I put it back, we have 3.99 volts. So guys, this is to indicate that the circuit can no longer charge the battery above the voltage that is displayed on the multimeter. And so guys, this also indicates that the circuit is efficient at charging lithium-ion batteries. So what this simple circuit does is that it steps down the 5 volt coming from the power supply to 4.2 volts. This circuit is very protective and protects the battery from overcharging. So if you want to charge more lithium-ion batteries, keep in mind that this circuit will not charge more than one lithium-ion battery. So if you want to charge more than one lithium-ion battery, you've got to experiment on your own and use a low-value resistor to replace the 2 ohm resistor on the circuit. So if you charge more than one lithium-ion battery with this circuit, there's going to be more voltage drop on the circuit. The voltage on the circuit might drop from 4.2 to about maybe 3.8 volts, and the batteries will not charge to its maximum. So right here, let's measure the voltage on the output of the power supply. And as you can see, we have 5.07 volts. And let's test the voltage on the battery. And as you can see, we have 4 volts. And as you can see, it's not going above 4 volts, it's just right there at 4 volts. And so guys, if you like this video, support the channel by hitting that subscribe button and giving us a like. Stay creative and stay safe. In this video, I'm going to show you how to build an effective low voltage auto cutoff circuit for a lithium-ion battery with only one component. This circuit is so effective that it will automatically cut off a lithium-ion battery when the voltage is at 2.5 volts. So guys, if you're new to the channel, hit that subscribe button and let's get started. And so guys, for this project, we're gonna need a 6 volt relay. You can as well use a 5 volt relay for the project. It's gonna work perfectly well. And make sure to test the relay to ensure that the contacts are all working. So now guys, we're gonna connect one terminal of the relay coil to the COM of the relay. And so guys, I made a video on how I built an automatic charger with just 2 components for a lithium-ion battery. This circuit was so effective that it charged the lithium-ion battery and caught the charging at 4.2 volts. So I'm gonna place a video down in the description below. So if you want to watch this video, just click the link down in the description. And if you've watched this video, notify me by commenting watched. And so guys, now we're gonna hook up some wires to the normally open of the relay contact, and also we're gonna hook up another wire to the coil of the relay. These are the points where we're gonna get our output from the battery.
I'd appreciate if you could let me know where you're watching from. Please leave the name of your country in the comments. It helps me understand my audience better. And no, this isn't AI, this is my actual voice.
Alright, sorry about that. So now guys, let's hook up a battery. But first, we're gonna measure the voltage of the battery. And as you can see here guys, we have a voltage of 4.0 volts. So the battery is fully charged. So now we're going to hook up the terminal of the battery. You can use any of the terminals of the battery, hook it up to the COM. So now I'm going to hook up my multimeter probes to the output of the relay.
So, the reason why we're doing this is to measure the voltage output from the relay. And so guys, if you like this video, support the channel by hitting that subscribe button and give us a thumbs up.
And so we're going to use the end of the battery to touch the coil of the relay, and as you can see, we have an output voltage of 3.9 volts.
So guys, this means that the coil has been activated and has drawn the COM to contact with the normally open. And that's the reason why we have an output.
So I'm going to try this one more time again so you can see what is going on. As you can see here guys, we have an output.
So now we're going to hook up a switch.
So the reason why we're using a switch here is to stop voltage from flowing from the battery to the coil when the battery is not in use. And so guys, in my previous video, I showed how to make an oscillator with a relay. And also in that video, I explained clearly how a relay works. So I'm going to place the link to that video down in the description below. And if you have watched the video, notify me by commenting watched.
Now, so guys, watch what happens when I turn on the switch. And as you can see here, guys, the coil attracts the COM, and the COM attaches itself with the normally open. And then we have an output. So guys, to be sure this is working, we're going to connect a load. So we're going to connect this DC motor to the output of our circuit. And as you can see here, guys, when I turn on the switch, the motor starts turning. So we're going to bridge the output of the circuit to see if it's going to stop. And as you can see, even as we bridged the output, the relay still turns on. So guys, this circuit works very well with a 3-volt battery, and it outputs the voltage as well. So let's test and see if it actually shuts down if the battery is low. So guys, we're going to use a low voltage lithium-ion battery. So guys, we're going to connect a very low voltage battery. But before we connect the battery, let's measure the voltage. And as you can see here, guys, we have a voltage of 2.5 volts. So now we're going to hook up the battery to the relay and see if it's going to turn on. So now we're going to replace the fully charged battery with the very low voltage battery. And so guys, a BMS circuit will stop outputting the voltage from a lithium-ion battery when the battery is at 2.5 volts or 3.0 volts. So now let's test if this circuit is going to do the same thing. And as you can see here, guys, the motor does not turn on, to indicate that the circuit has shut off the battery. And so guys, the reason why the circuit is not outputting any voltage is because the battery is low and it cannot energize the coil anymore to attract the COM to contact with the normally open. And so guys, comment down below, is this DIY build better than a BMS?
So guys, as you can see in this video, the circuit did very well by not outputting any voltage at all. And also guys, it did very well by protecting the battery and not allowing the battery to drain more of its power. So guys, place your comments in the comment section below. What do you think about this video? Remember, don't forget to subscribe, like, and share. Stay creative and stay safe. Goodbye.
Is it possible to build an automatic cutoff charger for a lithium-ion battery with just one component? Yeah, it is possible. So in this video, I'm gonna show you how to build a very effective auto cutoff charger for a lithium-ion battery with just one component. This circuit is so effective that it will stop the charging of a lithium-ion battery when the battery reaches a voltage of 4 volts. And for this build, you are not gonna spend a dime, because these components are very easy to find. So if you're new to the channel, hit that subscribe button and let's get started. So what is this component and where can we find it? This component is a full bridge rectifier that you can find in any power circuit. And also they come in different sizes depending on the wattage. I took mine from an old charger. You can as well take this from an AC bulb. The full bridge rectifier has 4 terminals. 2 terminals for the input and 2 terminals for the output. The input is indicated with an AC sign and then the output is marked minus and plus, which is negative and positive output. So how can we use this to charge a lithium-ion battery or to build an auto cutoff circuit for a lithium-ion battery? We are going to connect a USB cable to the inputs. The USB can be connected either ways. There is no need for polarity. And now we're going to solder some wires to the output of the rectifier where we're going to connect the lithium-ion battery. So let's hook it up and see if it actually works. So now we're going to hook up the circuit to a 5-volt charger and measure the input and also the output. So now we're going to measure the output voltage. So as you can see here guys, we have a voltage of 4.6 volts. So now let's measure the input voltage. And as you can see guys, at the input we have a voltage of 5.2 volts. So now let's hook up a lithium-ion battery and see if it's actually going to charge. So the maximum charge of a lithium-ion battery is 4.2 volts. And the output of our circuit is producing 4.6 volts. That is without any load. So if there's a load on the circuit, the output of the circuit will be 4.3 volts, as you can see here. So guys, this circuit will charge a lithium-ion battery and cut off the charging at 4.3 volts. And remember, this circuit will only charge one lithium-ion battery. If you want to charge more lithium-ion battery in parallel, you should use a bigger rectifier. So now we're going to measure the voltage of this battery and then hook it up to the circuit and see if it's actually going to charge. As you can see here, the voltage on the battery is 2.8 volts, which means the battery is very low. So now we're going to hook up the battery to the circuit and charge. But before we charge the battery, we're going to connect our multimeter to measure the voltage before we connect the USB. So as we hook up the USB to the power supply, the voltage increases, which indicates that the battery is charging.
So we're going to leave the circuit to charge the battery to its maximum, and then we're going to come back and measure the voltage again. So guys, after some minutes, the battery stopped charging, which indicates that the circuit has automatically cut off the charging. So now we're going to discharge the USB from the power source. And here guys, as you can see, the circuit automatically stopped the charging. And now we're going to hook it back into the power supply. And as you can see, there is no increase in voltage. This shows that the circuit is very effective at charging a lithium-ion battery. So guys, support the channel by giving us a thumbs up and also hitting that subscribe button. Stay creative and stay safe. Goodbye.